Okay, so we've been hearing the word factored a lot in vocab, and now we're finally doing our lesson on it. Hopefully this is a review. You've seen factoring before, but if not, this is so important. Factoring keeps coming up forever, and it's really hard to do higher math when you don't remember how to factor. You want to be very quick at it. So this first one, we're actually just going to be taking out the greatest common factor, not doing the normal factoring that we think of, but it's coming up. Okay, so something that's really important is the zero product property. This is a vocab word. So pretty much it says if A times B equals 0, then either A equals 0 or B equals 0, right? That's a pretty cool property, right? So if I have 3 times something equals 0, well, the something has to be 0, right? Whatever this is has to be 0, right? Because 3 times 0 equals 0. That's the only way for this to be true. And then alternatively, if I have something times 7 equals 0, well then that something has to equal 0, right? Because this is the only way this is true. So pretty much whenever you have something like this, you can set them both equal to 0 to solve, right? So just to like talk more about what we're doing, right? Like without factoring, this would be really hard to find, right? Back when we were doing like degree 1, right? So that would just be like 2x equals 4, and then we like divide both by 2 and we get x equals 2, or we get like 3x minus 4 equals 2x plus 1, right? And then we move everything over. This is all degree 1, right? The original problem, the highest degree is 1. And these are easy to solve by doing multi-step equations, moving things around. But it gets trickier when we're in degree 2. So when we're in degree 2, we usually want to do factoring, right? So we need to figure out what values of x makes this true. And in order to do that, we need to factor, right? Over here, when we were trying to figure out which values of x made this true, we could just do our steps. But here, we need to go a little more complicated. Okay, so we're going to use the zero product property to solve equations. So let's make a little note right here. One side of equation is 0, the other is polynomial factors, right? Factors is a vocab word, right? So these are factors, and this is the 0, right? Factors 0, factors 0. And then we can find a solution, which is the same thing as root, which is the same thing as 0. Right, and this is all vocab. Okay, so how do we solve this, right? We know that x minus 6 times x plus 5 equals 0. How do we solve that? So we're going to set them both equal to 0, right? So, okay, so we're going to x minus 6 equals 0. Or x plus 5 equals 0, right? And right here, this step, right? So if x minus 6 equals 0, well, we know we add 6 to both sides, x equals 6. Here, we minus 5 from both sides, we get x equals negative 5. So these are our answers. So if x times 6, the quantity of x minus... If the quantity of x minus 6 times the quantity of x plus 5 equals 0, then either x equals 6 or x equals negative 5. Right? And we can check that with our calculator. Right? So I have, let's try the 6 first. 6 minus 6, 6 plus 5, 0. And then we have 5, negative 5 minus 6. Negative 5 plus 5, 0, right? But if I do any other number, that's not going to work, right? If I do, let's do 4 minus 6, 4 plus 5, that doesn't equal 0. So these are the only two answers that will work. All right, let's try another one. So we have b minus 3 over 4 equals 0, and 4b plus 5 equals 0. So here we just add 3/4 to both sides. Even though it's fraction, it's not so bad. B equals 3 over 4. And then here we minus 5 from both sides. 4b equals negative 5. And then we divide both by 4. b equals negative 5 over 4. So these are our two solutions, right? Okay, and then the whole point of factoring is like the opposite of distributing. So this is sort of a nice little graphic, right? We're going from here to here, right? This is the distributive property. So we're going to multiply. And then if we're going from here to here, we factor. And then you could say, if you could think of it like undistribute, which isn't a word, but it sort of tells you, right? If I'm going from here to here, I'm factoring. I'm undistributing, right? If I go from here to here, I'm multiplying. So we did this, right? Multiplying polynomials. This is the opposite of multiplying polynomials. So the first thing that you want to do when you're factoring is to do the greatest common factor. And the greatest common factor is a vocab word. You'll hear me say GCF all the time. Okay, so when you're factoring, right, the first thing we want to do is 1, check coefficients, the numbers in front of letters. 2, check variables. Okay, so for this one, we first are going to check the numbers. So we have 15 and 20. And I'm going to show you a process for how to do it, but then eventually you can just do it in your head. So we're always going to take the smaller, right? So take smaller, list factors, right? So 15 can either be 1 and 15 and 3 and 5. And then you want to check largest first to divide, or let's say check largest factor first if divide, take smaller coefficient, if divide into larger coefficient, right? So first we're going to check 15 because 15 is our largest, right? So is 20 divisible by 15? No. Right? So I'm trying to fix this. Okay. So 20 is not divisible by 15. Is 20 divisible by 5? Yes. So we're going to take 5, and we're going to, right, we're going to do the opposite of multiplying. We're going to divide. So 15 divided by 5 is 3. 20 divided by 5 is 4. And if we look here, there's no common variables, so we're just going to leave them. Right? So this is our answer. Right? And to show the math real quick, right? 15 divided by 5 equals 3. 20 divided by 5 equals 4. And that's where these numbers come from. And you can always check your answer. And the way to check would be to do the opposite. It would be to multiply, right? So check by, let me say multiply. Right? So 5 times 3x is 15x. 5 times 4y is 20y. And we can see that it's the same. So we know that we did it correctly. Okay, so let's try another one. So we have our smaller coefficient, 12. We have 1 and 12, 2 and 6, 3 and 4, and then 21. Is 21 divisible by 12? No. Is 21 divisible by 6? No. Is 21 divisible by 4? No, right? We're going from, we're checking the largest factor. So we're going from largest to smallest, right? So we did 12, 6, 4, now we're going to check 3. Is 21 divisible by 3? Yes. And then they both, this one has 2 y's and this one has a y, right? So we could do 3 times 4 times y minus 3 times 7 times y. This is just me like writing it out really in steps so that you can see, right? We're going to pull out this 3 and this y. So 3y, and then we're left with 4y minus 7. But eventually you want to start doing this in your head, right? You'll be like, okay, what is the greatest common factor between 12 and 21 is 3. And then there's a y, so 3y. 12y divided by 3y is 4y. 21y divided by 3y is 7y, or 7. And this is it. And we can check. So 3y, 4y minus 7, right? We multiply. So 12y squared minus 21y. That's the same, so we know that we did it right. And this is also why it's really important to know your times tables, right? You want to be really fast with your multiplication facts so that you can think really quickly. Okay, 21 is divisible by 3 and 7, 12 is divisible by 3 and 4. Okay, so solve by factoring. So this is the same thing except for we're going the one extra step in solving. So, right? So the first step is we set it equal to 0. Second step is we factor. Third step, set factors equal to 0. Fourth step, solve. Okay, so this one is already equal to 0. So 1 is done. 2, we're going to factor. So they're both divisible by 5, and they both have an x. So we have 5x, 2x minus 3 equals 0. Third step, we're going to factor, or we're going to set factors equal to 0. So we have 5x equals 0. So this one, even though we're used to like saying like the parentheses, right, we could put like our little parentheses around it and we could see that's a factor, right? So even though it's a term on the outside, you could just put the parentheses and you can see, okay, here's one factor and here's the other factor. So we set them both equal to 0 and now we need to solve. So we divide both by 5, we get x equals 0 over 5. Anything, 0 over anything except for 0 is always 0, so that's the same thing as x equals 0. And then here, right, plus 3, we have 2x equals 3, divided by 2, x equals 3 over 2. These are our two answers. And let's check, right? Let's see if we did this right. So we have 10, 0 squared minus 15 times 0. That equals 0. We did it right. And then we're going to just pull that and take it again, and we're going to place a 0 with 3 over 2. Okay, never mind. 3 divided by 2 to the power of 2 minus 15 times 3 divided by 2. So that equals 0. So we found our two solutions, right? 0 and 3 over 2. So those are the two things that make this equation true, right? All right, let's do the other one. So 1, we just set them equal to 0, so we're going to minus 12 on both sides, or 12w. 2, we're going to factor, so they're both divisible by 6, and they both have a w to give, right? This has 2 w's, this is a w, so we have 6w. We're left with a w, we're left with a 2. We're going to set both the factors equal to 0, and then we're going to solve. Right, plus 2, plus 2. Awesome. And eventually when you start getting fast, you can literally go straight from 2 to 4. Like you could just see in your head like, oh, this one's going to be 0, this one's going to be 2. So once you get quick, that's what you're going to do. All right, we are almost done. Okay. So this one's asking us to factor, this one's asking us to solve. So this is very similar to factors versus solutions, the vocab. Right, so this is just asking us to factor and not to solve. So the answer should, this is almost like simplify, right? Solving means I want my answer to have an equal sign, right? Answer needs equal sign, right? That's what solving means. Okay, so let's factor this. So this one, remember first we check the numbers and then we check the letters. So this one is our smallest, so it's 2 and 1. So they're all divisible by 2. And then this has 4 g's to give, this has 2 g's to give, and this has 1 g to give. So altogether, the maximum that they can all give is just 1. So this becomes negative g cubed plus 7g plus 3. And that's it, we factored it, right? And then here, so 1, we're solving, we're going to move everything to one side. We're going to set it equal to 0. 2, we're going to factor, so this is divisible by 3, and this is also divisible by 3. And they both have a y to give. So right, 15y divided by 3y is 5. We're going to set the factors equal to 0. We're going to solve. That's it. I just want to go over an example really quick. So let's do like, let me think of something. Let's do 24x cubed plus 28x squared. Okay, so if we're factoring this, you might think, okay, they're both divisible by 2, right? And you try that, and you see that there's 2 x's. So you have 2x squared, and we get 12x plus 14. So the tricky thing with this is that this isn't done because these can both be factored even further, right? So even though this is like a correct step, pull out 2x squared, right? These two can still be divisible by something even more. So right, these are both divisible by 2 again. So what we want to do is 2x squared times 2, 6x plus 7. And then this would be a 4. So this would be correct. This would be half off. This is not simplified. So when you're factoring, you want to be careful that you're going as far down as possible, right? So originally what we should have done is we should have realized that in here they're both divisible by 4. But it's okay if you forget that. You just have to like look at it again and see, okay, what else are these both factored by something? Can they both be divisible by something? And then you go to get to the correct answer. So make sure that you're fully factoring in the same thing that you fully simplify, right? Similar to, right, 24 over 28. If you gave me 12 over 14, I'd say this is half off. You didn't simplify it, right? It needs to be 6 over 7, right? So same with this. If you can factor out another factor, you need to, or else it's not correct.